Hi, my name is Guang 12 years old. For this lesson, we'll be continuing on with the techniques and applications for definite integration. For this lesson of definite integration, we have double integration, and then the boundary is d, and then e to the power of negative y squared dx dy, and we have d, and the boundary of d is bounded by x is bigger or equals to 0, while x is also smaller than positive infinity. While y, on the other hand, y is bigger or equals to x and smaller or equals to 2x. Okay? Alright, so over here what we have is that, so supposedly over here we can integrate, right? But what are the boundaries and what is the area D is bounded by? So apparently the area D is bounded by is so apparently over here we have the y is smaller or equals to 2x, so we have, and we also have the y is equals to x, right? So what we'll have here is, over here for the y is equals to x, and then we will also have y is equals to 2x, whereas it will be like this, okay? So these are the two lines for y is equals to x and y is equals to 2x. So now that we have gotten this part, what we are going to have next is, so over here is supposedly the area in between, right? But what about for x? What about for x? So for x, it is from 0 to positive infinity, right? Whoops. And then we have the 0 to positive infinity. So it will be as long as it is above the x-axis or at the x-axis, which will become like this. Okay? Alright, so what we're going to have now that we know the area bounded, we can know the boundary over here. But if we want to know the boundary, we also have to know whether we're integrating with respective to x first or with respective to y first. Well, if we do it with respective to y first, it will be impossible because that, unless it is 0 to infinity, which is a special case, but over here if you do it with respect to y first, no, you cannot do it. So we will do it with respect to x first. So when we do it with respect to x first, we'll go from here to here, which is from y over 2 to y. Well, for y this time it will be from 0 to infinity. Well, you still cannot straight up use the special method because that the y over here. Well, what we can do now is to straight up integrate for dx, the integration for the dx, whereas we're going to have x and then y over 2 to y. Now that we have gotten this part, we can sub inside both of these, whereas we'll have y minus y over 2. Whoops. And y minus y over 2 is basically y over 2, whereas you have a half in front and you have 0 to infinity e to the power of y times e to the power of negative y squared dy. Well, you see this y over here, right? You can put it inside this dy and you get dy squared, right? But when you change it to y squared, this will have another half. We'll change this to 1/4. And in order for both of them to have negative over here, we'll also have a negative in front, okay? Well, that will just mean that we have to add a bracket here. So here is basically e to the power of x dx, and we can integrate it and it will become okay, so over here, if we substitute the boundary infinity inside, you're going to have a 1 over infinity, which ends up with a 0. So we will ignore it, and then we'll minus this 0, whereas we'll have the negative for this minus, and this negative will cancel each other out, and you will get 1 over 4, and then e to the power of 0 is basically 1, so our answer here will be 1 over 4. So for this example, what we mainly use is that we just integrate it with respect to x first, then after that integrated it. Well, that will be all for this example. Now moving on to the next one, moving on to our next example. Here we have double integration e to the power of negative 2y squared dx dy. And the d is the boundary over here, which is bounded by y equals to x, y equals to 1, and the y-axis. So over here, what we have for this part is so first we have our y equals to x over here. And then after that we have our y equals to 1. And then after that we also have our y-axis, whereas we will end up with this area. So this is the area bounded by, that d is bounded by, okay. So what we'll have here is that, so we can choose to integrate with respect to x first, or we can also choose to integrate with respect to y first. But over here, we cannot integrate with respect to y first in this case, because that over here, e to the power of negative 2y squared, you cannot integrate it. So here so instead we'll integrate with respect to x first. Whereas, so for y, the boundary will be from 0 to 1, while for x, the boundary will be from 0 to y. So what we'll have here is that, so we will integrate x straight away, because for this you will straight up just have x. And then when you sub it in, the 0, it will still be a 0, so the behind part we can ignore it, while the in front part you will have y. So we want to change the dy over here to be the same as this part, to make it e to the power of x dx and make it actually solvable, right? Alright, so for this part what we're going to have is, so y over here, you place it inside and you have y square, but that means that you have a half in front. But over here for this side you need a 2, so if you need a 2y squared, the half from the y square and the half from the 2 will time together and give you 1 over 4. And then here we have negative, which means that we'll also need a negative over here. And thus, this is how we get the e to the, and this is basically just like e to the power of x dx, and the y, the 2y's get the y squared with a half, and the 2 will get another half, making it 1/4. Now that we have gotten this part, we can easily integrate it, and we'll get e to the power of negative 2y squared. Basically like the e to the power of x. And now we sub this in. So if we sub 1 in, you have negative 1 over 4e squared, right? Because this 2 isn't actually inside the square, and then here minus and this negative will cancel out and become a positive, while this 0 times here will be 0 squared times 2 will still be 0, so e to the power of 0 is basically 1. And thus here, this is what we have. So mainly for these two methods is that so this is the answer for this example. So for both examples for this lesson, we mainly just decided that for this, because that if we integrate with respect to y first, we cannot solve it, so we had to integrate with respect to x first and just integrate it, okay, and make the y part solvable. And that'll be all for this lesson. Last but not least, thank you for your watching.